Hi there, I'm William, and this is Standard 29. Standard 29 is mainly about the unit circle and finding terminal points, coterminal angles, and reference angles on the unit circle. So, our objectives for this video are to recreate the unit circle. The unit circle is extremely important to Standard 29 and the majority of Precalc because it allows you to find the angle measurements, reference angles, and terminal points of different triangles and allows you to solve multiple different kinds of problems. We will also be able to understand what terminal points are, what coterminal angles are, what reference angles are, and we need to also be able to convert between radians and degrees, and we need to also understand why the unit circle exists. And we need to be able to solve 5 different problems. You should be able to draw your own unit circle, and by the end, be able to convert between radians and degrees. So, starting right off the bat, first thing, the most important thing you really need to know is the unit circle. So, I'm going to fill out the unit circle really quick here, and I will be able to explain what is what and why certain things are the way they are real quick. Now that the unit circle is completed, I'm going to tell you why all of these little points matter. Firstly, you look at the degrees. The degrees in this situation are from 0 to 360. That is a normal angle thing. Angle measurement: 30 degrees, 45 degrees, 60 degrees, etc., etc. Right here, you have radii. Radii I'll get to in a second. And then right here you have terminal points. I made a little error here. This is supposed to be 1, 0. This is 0, 1, -1, 0, and 0, -1. Those points are based on your xy coordinate plane. In all these situations, this tells you the length of the radii on each of the radii of the circle. So, in the unit circle, there are 2 different kinds of triangles, and those are the only triangles you have built into the unit circle. There is a 30, 60, 90 triangle and a 45, 45, 90 triangle right here. These are what they look like. So, based on other rules of triangles, all triangles that are 45, 45, 90 have the hypotenuse as x root 2, with this length being x and this length being x, because this length and this length are the same. With 30, 60, 90 triangles, a hypotenuse is 2x, this is x, and this side is x to the root x times root 3. All of these are built into the unit circle. And if you look at the terminal points on each of these triangles, you can tell that these, root 3, x root 3, and root 2, all apply to these pieces. So you have root 3 right here, and you have root 2 right here. A 45, 45, 90 triangle has root 2, and a 30, 60, 90 has root 3, as you can see. And based on the other measurements, etc., etc., you end up with these different terminal points. That's why the terminal points are the way they are. Going into radii are a different way of looking at degrees or angle measurements. The way I best remember radii is that there are 12 radii in the unit circle in 180 degrees. So, right here, every 15 degrees, as so, is 1 radii. 15 degrees is equivalent to 1 radian segment. So, you have 15 degrees, 30 degrees. 2 of those becomes 2 pi over 12. You simplify this, it becomes pi over 6. Right here, you have 3 pi over 12. And by simplifying that, it becomes pi over 4. This applies to every single other piece. Now, when you go around the unit circle like this, you're adding another additional 12 radii spaces. So, you have pi right here, and you restart. But you're going, instead of growing towards 1, you're going towards 2 pi, because that's the nature of the unit circle. 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, etc., etc., based on each little radii section being equal to 1/12 pi. So you're able to add all these up. And that is the unit circle, and that's why the unit circle the way it is. Now that we've completed the unit circle, it's time to do some practice problems. So, the first practice problem is, if you are given negative 405 degrees, what is the coterminal angle and what is the reference angle? So, looking on the unit circle, there's obviously no negative 405 degrees because that's over 360 degrees. The first step to finding the coterminal angle and reference angle of negative 405 degrees is adding 360 degrees. So, if we start with negative 405 degrees, we add 360 degrees, so we have negative 405 wherever it is, but we're adding 360, and that equals negative 45 degrees. Negative 45 degrees is on the unit circle. Going a negative degree direction is just going down, opposite direction, which means that negative degree direction based on the unit circle is 315 degrees. So, the coterminal angle is not that exact angle of what we're looking for. We now know that it's 315 degrees, but a coterminal angle is opposite, other side, of terminal of the other side. So, if we know that 315 is our first angle, we're looking for the coterminal of 315. Coterminal is essentially just the opposite, so you're just going to go directly opposite. Directly opposite ends up being 135 degrees. So, your coterminal angle for negative 405 is 135 degrees. Based on right here, you have 135 degrees. So, the coterminal of negative 405 is 135 degrees. The reference angle. The reference angle is essentially how far away the degree is from the x-axis. So, looking at this degree right here, we're not looking at that was coterminal. Now we're looking at 315. The reference angle is how many degrees away it is from the x-axis. Based on right here, this is 30 degrees, and this is 15 degrees. So, it's 45 degrees away. So, the reference angle for negative 405, reference angle, equals 45 degrees. That's always going to be a positive degree. You're never going to have a negative reference angle, ever, because it's like the absolute value. That's how far away it is from the x-axis, not what degree specifically it is. Practice problem. This practice problem asks us to find the terminal point of negative 960 degrees and the coterminal angle of negative 960 degrees. So, to find the terminal point of negative 960 degrees, firstly, we need to find the degree measure that's on the unit circle. Obviously, 960 degrees, negative 960 degrees, is not on the unit circle. So, we're going to add 360. So, 960, right here, you have 960, you subtract 300, you add 300, you add 300, you're there, you add 360, you add another 360, you're there, and then, if you're still going negative, you go negative 240 degrees, which you end up here. So negative 240 degrees is right here, because you're going in that opposite direction right there. So, the terminal point of this is going to be negative 1/2 and root 3 over 2. Alright, so we know that. Now we need to find the coterminal angle. Coterminal angle, all you have to do is cut straight across, and you look right across. If you've got that right there, that's your point. But because it's negative 240 degrees, what you have to do is you have to have negative 240 plus 180 is negative 60 degrees. But that's still not positive. Our coterminal angle needs to be within 0 and 360 degrees. So what we're going to do again is add 360 degrees which means our coterminal angle ends up being not negative 240, not nothing like that, but ends up being 300 degrees. So our coterminal angle is 300 degrees. Time for another practice problem. This practice problem, we are given negative 3 pi over 4. This problem is in radians. So usually when you have radians, you're going to want to convert to degrees. But that's a side point. So we're given negative 3 pi over 4. We need to find the coterminal angle and the reference angle. The coterminal angle needs to be within 0 and 2 pi, or 0 and 360. So it needs to be positive. And the reference angle needs to be in radians as well, which makes it a little bit more complicated. So finding the coterminal angle, firstly we have to find what the exact value is. If we have 3 pi over 4, if you look at this, you can see that 3 pi over 4 is right here. And if you're going to find negative 3 pi over 4, all you have to do is like you did in the last problem. You flip it over, you look right across. There, you're at 45 degrees in this direction. Looking at each quadrant, not really 45 there, but right here. You look at that right there, which means that is negative 3 pi over 4. Negative 3 pi over 4. So that's what you end up with. And now that you know what your angle is negative, I believe that would be negative 135 degrees. When you need to find the coterminal angle, it's negative 135 degrees. It's negative, it needs to be positive. Negative 135 degrees plus 360 equals 225 degrees. So 225 degrees is our coterminal angle. So we know that 225 degrees is our coterminal angle. Then we need to find the reference angle. The reference angle needs to be in radians as well. Reference angle is how far, again, something is from the x-axis. So all you have to do is look right here, say, what is our reference angle? How far are we from the x-axis? Right here, that's just 45 degrees, because if you look here, you've got 45 degrees in this piece. You obviously know that because you're just counting by 15 degrees each piece. Right here, you're just counting by another 15, 15, and another 15. So you know your reference angle is 45 degrees. All right, so that answers those two questions. For an additional practice problem, we need to find the terminal point and the reference angle for 16 pi over 3. Let's write that out. 16 pi over 3. So, as I did earlier when I was converting to radians, while I was looking at radians, I was able to use the unit circle to rely on finding my radian point. In this situation, you don't have 16 pi over 3 on the unit circle. So what you need to do, or at least what I do, is I convert this to whatever your number is over 12. In this case, you have 3. If you want to convert the denominator to 12 to make it easier to see how you are on this scale, you're going to have to multiply by 4. So you multiply by 4, and you multiply by 4. 16 times 4 is 64. 64 pi over 12 is a fairly large number. So if you have 64 pi over 12, that's a very large number. What you need to do now is to subtract 360 degrees from this. I'm going to keep it in radians and not convert it into degrees. So, because 360 degrees is equal to 2 pi, all I need to do is subtract 2 pi from this ratio right here. If I subtract 2 pi, but 2 pi is over 1, so I need to convert the denominator to be the same. In this situation, if I want the denominator to be 12, this is going to have to be multiplied by an additional 12, so that's going to turn into 24. So 64 minus 24 is 40. 40 is still a little too big because it's not within the 24 range. So what I'm going to do again is I'm going to do 40 minus 24. I'm going to subtract another 2 pi, 24 pi over 12, which is equal to 2 pi. And that ends up giving me 16 pi over 12. 16 pi over 12 is within the unit circle because it's below 24 pi over 12. What you can do now is simplify and look for that point on the unit circle. If you simplify, what you're able to do is divide by 2, 8 pi over 6. Divide by 2 again, you end up with 4 pi over 3. 4 pi over 3, you look for that on the unit circle. Alright, there it is right there, 4 pi over 3. And all you have to do is say, okay, if I'm finding the terminal point, those are those two. Remember, if you have something in the third quadrant right here, this is the third quadrant, like a normal Cartesian format graph, anything in the third quadrant is going to be negative, negative. Make sure your terminal points are always negative. In this quadrant, make sure your y value is negative, your x value is positive, and so on and so forth. Just make sure your terminal points are always in the right sign form. Alright, so you have negative 1/2 and negative root 3 over 2. Those, right there, negative 1/2, comma, negative root 3 over 2. Those are your terminal points. If we find the reference angle in degrees, reference angle is how far we are from the x-axis. All we need to do is look and say we've got 15 degrees here, plus 15, plus 30, that's 30 degrees right there, and that ends up being 60 degrees. So our reference angle equals 60 degrees. Alright, and those are those problems.